Hello everyone, welcome to EDU for sure. Today we're going to see how to find the inverse of a matrix. So in order to find the inverse of a matrix, what actually the step is, we're going to see that. So two non-singular matrix A and B of same order is said to be inverse of each other. What do you mean by this? So here the inverse of element here to non-singular matrix, it mean what? That the determinant of A and B will be not zero. Singular matrix means what? Whose determinant will be zero. So here two non-singular matrix I'm talking about A and B whose determinant value will be zero. If you have seen my previous lecture on determinant, then you might be aware how to find out the determinant of a matrix. So for two non-singular matrix A and B having a same order, for example, A is of 3 cross 3 and B is of 3 cross 3, how we're going to find it out the inverse of each other. So let's start here. Here A into B equal to I is equal to BA, both are same. As I've already said you, 2 into 3 equal to I equal to 3 into 2, both are same. I mean to say that if I say you 2 into 3 or 3 into 2, both will give you same result, right? 2 into 3 will give you 6. Similarly, 3 into 2 will also give you 6. So here 2 into 3 will give you 6 and 3 into 2 will also give you 6. So this is both are same. So here also A into B equal to I equal to BA, both are same. But now what do you mean by this I here? I is an identity matrix, and if you remember, if if you wanted to correlate this I with this AB, then here the order of matrix I should be equal to AB. That means order of A and order of B equal to order of I. So what do you mean by this identity matrix? Identity matrix, it mean that the diagonal element should be 1 and the order will be equal to this A and B, or the order of A and B. So let's see that what is an identity matrix. So here identity matrix will be like this, where the diagonal element will be 1, rest other element are 0. So here you have to make LHS, that is left hand side, equal to right hand side. It means that the resultant matrix that you will get when you multiply matrix A and B should be equal to this I. It means that should be equal to this. So here I'm taking an example and assuming that A and B is of order 3 cross 3. So when I will going to make it equivalent to the left hand side identity matrix or right hand side identity matrix, I should say that right hand side identity matrix and left hand side this multiplication of two non-singular matrix or this BA should be equal to this one. So here A and B order should be also 3 cross 3. So like this it works. Now the actual motive of this inverse of matrix is how we're going to find it out, the inverse of matrix. So inverse of matrix is represented with A to the power minus 1, which actually means inverse. It is similar to 1 by A. When you are going to take A above, it will be represented by this. I mean to say that if you take 1 by A, for example, you have 1 by A can be any value, right? And if you take A above, your A will be like A inverse, right? When you will going to take A above, or when you take this denominator above, it will be represented by A inverse, right? So similar thing is written here, that what is this inverse? Inverse of B is also denoted by B to the power minus 1. It will be represented by B to the power minus 1. And further, the inverse of this multiplication of A and B matrix will be represented by B inverse and A inverse. So you can represent it in this way also. But before that, how you're going to find out the inverse of a matrix? So let's see that. Let me rub this. So here the inverse will be represented by this minus 1 to the power minus 1. And here A is matrix. Suppose A, you have a matrix 3 cross 3. How you're going to find it out, the inverse of a matrix? If you remember in my previous lecture, adjoint or co covector and cofactor and minor, then you might be remember how we're going to find it out. In this lecture, I've explained you what is actually the minor, and with respect to this minor, how you're going to find out the cofactor. So I told you that for this A11, if you want to find out the minor, then you have to hide that row, this row and this column. So you will get this minor with respect to A11. I repeat once again. If you want to find out the minor for this A11, then it will be hiding this column and this row where that A11 is occurring. So this will be the minor. And what will be the cofactor? As you can see, A11 is having cofactor will be always minus 1 to the power 1 plus 1, because here for A11 the I will be your this 1 and J is also 1. So when you are going to do 1 plus 1 to this minus 1, it will going to give you minus 1 square, which will be 1 only. So in that way we going to find it out, cofactor and minor, and the cofactor will be look like this. Similarly, when you want to find it out A12, so it will be 1 plus 2, that is I value here will be your 1 and J value is also here 1. But for A12, the I value will be your 1 and J value will be your 2, right? So like this it works. So I hope it is clear to you what is minor and cofactor, and then you can derive, or you can find it out inverse very easily here. So let's go to this. And in adjoint, in my previous lecture I've already explained what is adjoint. Let me rub this and explain you once again. So in my previous lecture I have explained you that how to find out the adjoint. If you find it out the cofactor, then you just have to transpose this matrix, so you will get the adjoint of A. I repeat once again, once you find it out the cofactor, as I explained in my previous lecture, if you find out the cofactor, just transpose this. Transpose means converting every row to the column. You can see here A1, B1, C1 is your row, it become column now. A2, B2, C2 is your row, it become column now. A3, B3, C3 is your row, it become column now. So once you transpose this, converting every row to every column, it will become adjoint of A. So let's come to this inverse part that we were talking about. So here, in order to find out the inverse, what you require? Adjoint of that particular matrix A, then mod of A, which is the determinant. This is A is your the determinant. If you remember in the determinant part, I've explained you how you're going to represent the determinant of a matrix. Suppose the name of a matrix is B, then it will going to come B here. And you have to find out the matrix in what way? A into D minus CD. If it is of 3 cross 3, then you will going to find out in the way of, as you find out minor, you will going to hide this row and column for particular A, and you will going to find it out this difference as you can see here. I've already explained it in my previous lecture. So now what you require is you have to find it out the transpose of the cofactor and then divide it by determinant, so you will get the inverse of matrix. For example, this is your cofactor. Once you get this cofactor, divide it every element by the determinant of the matrix A, so you will get the inverse of that matrix. So now here, if I talk about AB inverse, then what you will going to do? You will going to multiply first A and B. You will going to then find out the cofactor of that. You will going to transpose this, and then you will going to divide it. So what are the steps for this? So this is the step of finding. First you multiply A and B. I'm talking about here AB. But if you are working on a single matrix A, then you will just going to find out the cofactor first minor, then cofactor, then adjoint it, and then just divide that the whole resultant, like this resultant you will going to obtain when you're going to do adjoint, then divide it by the determinant of that matrix. So in this case you will going to divide it by determinant of AB, so then you can correlate it with identity matrix. So in this way we're going to find out the inverse of matrix. So I hope it is clear to you how to find out the inverse of a matrix. So these are the steps. We're going to see the example. So as I said you here, that you have to convert this matrix, the resultant matrix that you obtained from the cofactor after performing cofactor, you have to convert this into the adjoint matrix. And how you're going to obtain that adjoint matrix? By transposing this matrix, by performing transpose operation. So what is the transpose operation? Transpose operation is converting every row to the column. So here 369 is there, your first row. It will become a first column. So let's see the example. You can see here 369, that was the first row, will become your first column now. 036 is your column now. So here I converted every row to column, and after performing the transpose operation, I got this. So now you will going to find out the determinant of this matrix. The determinant of the matrix, you will going to find it out here. And how you're going to find out the determinant? As I have explained in my previous lecture, the determinant you can find it out first, as it is 3 cross 3. So for this element with respect to 1, you will going to hide this column and this row, and you will going to perform operation on this. So 1 into minus 5 into 1 will be minus 5, then minus 2 into 4 will be minus 8, will become plus 8 now. I repeat once again, 1 into minus 5 will become minus 5, then minus, what is the multiplication of minus 2 into 4? Minus 8. So it will become plus, minus minus will become plus, as you might have studied in school also, that minus minus will become plus, right? So here, if you remember, then now it will become plus. So similarly, the next quadrant, I told you for next quadrant, it will be your minus 4, right? So here for the next value, which row and column you will going to hide? For next value, you will going to hide this row and this column. So now with respect to minus 4, the element that you will get as a minor is this one. So minus 2 into 1 will be minus 2, minus 1 into 4 will become minus 4. Now as it is minus 2, that's why we are taking minus 2. If in case of this plus operator was there or plus value was there, we could have taken plus. So in this way, you will get the determinant value. Now this is our final inverse operation, where the formula is 1 divided by mod of that A, that is the determinant of that particular matrix, into adjoint of A, which is your this step that you got after performing a transpose operation on cofactor value. Let me write down here so that you can get it. So after performing an operation, transpose operation on cofactor value, you will get this adjacent A. So if you remember that I said you that what is an means the formula for calculating the inverse is this one, right? A inverse adjacent A mod A, right? So now here, when you will going to do the operation, So 1 by 9, this is your determinant value. This is your adjoint matrix that you got it here. So when you divide it, you will get the inverse value. You can either convert it into the decimal, like 1 divided by 3 will be equal to approximately 0.33, or you can keep it like this also. So I hope it is clear to you how to find adjoint of matrix and how to find the inverse of matrix. So in this way we can find out the inverse of any matrix. So the inverse of matrix is represented by this. For here we are finding inverse of matrix A. So it is represented by A to the power minus 1 equal to 1 by mod of A, or you can say the determinant of A into adjoint of A. So here in this way we will going to find out the inverse of matrix. So this is your determinant process. This is the way of finding out the determinant, which I have already explained in my previous lecture. This is the adjoint A, and this is the formula for calculating the inverse of matrix. So I hope you find this session informative and useful. So we will going to share this informative session with you, and keep learning and enjoy learning this inverse of matrix and other Python stuff. Practice well, and we're going to keep sharing like this session with you always. Thank you.